All right, let's jump right in. We're going to tackle a skill that's absolutely fundamental for any Java developer, handling files.
You know, when you think about it, the answer is all about file handling. That's the magic behind how programs create a memory for themselves, a way to remember things on your computer. And guess what? Java gives us an awesome toolkit to make it happen.
So, here's our game plan. We'll start with why files matter in the first place. Then we'll peek inside Java's toolkit. After that, we'll get into handling different kinds of data, cover the 4 basic operations you'll use all the time, and wrap it up with some modern methods and best practices.
Okay, first things first. Let's talk about the big why. I mean, why do we even need to mess with files? Can't our programs just, keep everything in memory?
Well, here's a good way to think about it. Memory, that's like a program's short-term thoughts. As soon as you close the application, poof, it's all gone. But files are its long-term memory. They're like a permanent journal that the program can write in and read from later. This is what lets it pick up right where it left off, which is kind of crucial, right?
All right, so now that we know why we need them, let's open up the toolbox Java gives us. When it comes to file handling, there are really 2 core ideas you got to get your head around.
So point number 1, everything, and I mean everything, starts with the file class. But here's the catch, and this is a really important detail. When you create a file object in your code, you're not actually making a file on your hard drive. Not yet. Think of it more like a blueprint or an address. It's just an abstract path that points to where a file could be or where one already exists.
Okay, so if the file object is the address, how do we actually get data to and from that address? That brings us to I/O streams. These are basically the delivery trucks. They're the pipelines that carry your data byte by byte from your program out to the file, and then from the file back into your program.
Now, this is super important. You have to know what kind of data you're sending through those pipes. Because Java treats raw binary data, like an image or a sound file, very differently from how it treats plain old human-readable text.
And that's where you have to make a choice. You've got 2 main paths. If you're working with anything that isn't simple text, we're talking images, audio, video, you name it, you're going to use byte streams. But if you're dealing with text, especially if you want your app to work with different languages and special characters, then character streams are absolutely the way to go. They're built to handle Unicode, so they won't mess things up.
Okay, we've got the tools, we know the difference between our data types, now let's get our hands dirty. We're going to walk through the 4 core operations you will do constantly: create, write, read, and delete.
First up, creating a file. It's pretty straightforward. Before you can write any data, you need an empty container on your computer to put it in. Simple as that.
So remember that file object we said was just a blueprint? Well, to actually build the house, you call the createNewFile method on it. This is what physically creates the file on your disk. It'll tell you true if it worked, or false if, whoops, a file with that name already exists.
All right, file created. Now it's an empty box. Let's put something inside. When you're writing text, a really simple and effective tool for the job is the FileWriter class.
And just like it sounds, you use the write method. You just pass it a string of text and boom, it sends it right into the file. Your data is now saved.
Okay, saving data is only half the battle, right? It's pretty useless if you can't read it back later. Now, you could use something like FileReader, but honestly, the scanner class is often a much better choice. Why? Because it's really good at breaking down the input for you, line by line, or word by word.
And you'll see this pattern all over the place, using a scanner inside a simple while loop. This lets you just chew through the file one line at a time until you hit the end. It's just a really clean, efficient way to process text files.
And last but not least of our basic 4, cleanup. Sometimes when you're done with a file, you just need to get rid of it. And luckily, Java makes that super simple. You just call the delete method on your file object, and that's it. The file is gone from your disk. That pretty much covers the basics of file management.
Okay, so knowing how to create, read, write, and delete is great. That's the foundation. But to write code that's clean, robust, and professional, you really need to follow some key best practices to avoid some classic mistakes.
And this right here, this is probably the #1 mistake that new developers make. Every single time you open a file stream, it's using up system resources. If you forget to close it, and it's easy to forget, you create what's called a resource leak. Do that enough times, and you can slow down or even crash your entire application. It's a big deal.
So, what's the fix? The modern, foolproof solution is the try with resources statement. It's amazing. All you do is declare your file stream inside the parentheses right after the try keyword, and that's it. Java guarantees that it will automatically close that stream for you when the block is finished, even if something goes wrong and an error is thrown. It's a simple change that makes your code so much safer and more reliable.
But it's not just about safety. Modern Java has also given us more powerful and efficient tools. Since Java 7, we've had the new I/O API, or NIO.2. This gives us the Files class, which is a powerhouse. It lets you do really complex file operations, often with just a single line of code. It's a huge step up.
And then, Java 8 took it to another level by tying file handling directly into the Stream API. With a method like files.lines, you can treat the lines of a file as a stream of data. The key here is that it's processed lazily. What does that mean? It means it only reads a line from the file at the exact moment it's needed, instead of loading the entire, potentially gigantic, file into memory all at once. For working with massive files, this is an absolute game changer for performance and memory usage.
So there you have it. You've got the whole toolkit now, from the classic I/O classes all the way up to the modern, super efficient Stream API. Giving your applications a memory, a way to persist data, is such a fundamental part of programming. It's what turns a simple script into a real application. So, the only question left is, what's the first thing you're going to teach your program to remember?